Good afternoon, everybody. My name's Roy Bailey, and I work for the UBS Investment Bank. Not a bad crowd, considering the competition I've got on this particular slot, I would say. I was expecting a few less. But this presentation is a presentation that I gave earlier in the year on a meetup to explain to people the story, if you will, the people story and the database choice story that UBS made some years ago on Cassandra. And it's quite a high-level story. Could I just ask how many people in the audience have got Cassandra live in production? Sort of half of you? Okay, and then the rest of you perhaps investigating and thinking about it. I'd say this is maybe useful to those thinking of adopting Cassandra, and those of you who are already in production, there's probably not much that's very new here. UBS Neo. I work, it falls under the e-commerce department, but UBS Neo is the platform that I work for. There's a little URL there if you want to know a bit more about it. You can punch that in and have a look. It's got a microsite. But this platform was a very bold initiative nearly 5 years ago now to rebuild a client-facing application across the entire investment bank, and it's the Neo platform that introduced, if you will, the new innovative database technologies onto the stack. So where did we begin? As I say, UBS Neo was a very large initiative nearly 5 years ago to consolidate many client-facing applications that the bank already had. Those applications were in themselves very good. They, individually, they could win awards for certain functionality in their particular field. But what was clear was that there was no unified identity for UBS. There was no consistency around the look and the feel, the behavior, and the color schemes even. So UBS wanted to pull that together and create a much more consumer-driven identity around the client-facing application that would hit all of the different asset classes, all the different areas of the business and the client base, and bring that together. So one of the areas that the bank needed to present information from was the time series data. And at the time, we had a lot of departmental systems that would collect time series data, dotted around the globe, having been built up from, 5-10 years ago maybe, to service a particular customer base in that region. And when we came along looking to build out a global platform that was going to hit that time series data stores, to chart that data, it created a new kind of demand that those systems simply weren't designed to handle. And during some of the testing that we were doing on those time systems applications, we would bring that down in tests simply because we had so many users hitting them, trying to pull back large volumes of time series data. So this really presented the problem that we faced, as I say, nearly 5 years ago when this initiative was started. We needed to find a way of serving time series data very scalably. This gives a pictorial view of what I've just said. We have 7 data centers across the world, but a lot of the departmental systems that had time series data on them, they had been built in a particular region for a particular vertical of the business, and they simply weren't up to the idea of having global users of the volume that we were looking to service coming in and hitting those departmental systems directly. So this is where the solution of Cassandra came in, was to sit that between the departmental systems and our front-end user interface, and to really start collecting the data out of these systems that were mastering, if you will, the time series data, and providing very fast reads wherever we were in the globe to the front-end system so that it was extremely quick, didn't present any load. protected the underlying time series systems. It pulled the data up from those systems on a daily basis to refresh the Cassandra distributed cache, if you will. And that was why Cassandra was chosen. That was the problem 5 years ago, that was the problem that Cassandra was brought in to solve. So why did we choose Cassandra? Obviously, at the time, there was a lot of investigations on a number of technologies, and 5 years ago, of course, Cassandra wasn't on version 2.0, and it didn't have a summit, as it were. It was compared against a number of other choices at that time, but to summarize, the fact that it was able to globally replicate across all of our data centers, the fact that the write speeds were very, very good for uploading that data every day. And obviously, if you look at the use case pattern that we have, the eventual consistency really wasn't an issue for us because we're loading end-of-day price data up at the end of the day, ready for the following day when we have lots of global users hitting that Cassandra store. So there's plenty of time for the global replication and for the latency there. And obviously, the storage itself, as you've probably seen if you've either used Cassandra or you're investigating it, you will have seen that time series comes up again and again as a very, very good fit for the time series, for the Cassandra storage model. And I'll come on to that a bit more later. But these were the reasons why Cassandra outbid the other contenders at the time. We did face some challenges, though. 5 years ago, remember, Cassandra was still in beta. It was still on a 0.6, I think, at the time we started. That is not the traditional pattern of a big enterprise investment bank where established products and vendors, proprietary vendors and managed services, that tended to be the rule. So it was a major shift in thinking to be able to bring in something that was firstly open source and secondly not even on a 1.0 release. But I think that highlights, if you will, the robustness behind the Cassandra engine, the fact that people like ourselves, and I think Credit Suisse as well mentioned in earlier, that they also picked this up at version 0.6, 0.7 around that time. So it kind of goes to show that even in those early days, this was not a fragile system. This was something that we were picking up to solve real problems, and that's a good credit to it. Documentation at the time was very hard and limited. Again, we're on 0.6 version, so the only documentation you had was very much with the forums and a lot of that was blocked from the internal internet policies, so there was a lot of working around that, circumventing that. And it took several months, obviously, of effort to put that together because there simply wasn't the expertise available, either in the bank or outside, and there wasn't readily available documentation, and things were moving quite fast at that time as well. So it did present a number of challenges. So what did we store? Like I say, the initial problem was our time series data. But what became apparent very, very quickly was once we had Cassandra in our mix as an available data store, there was a number of other use cases that quickly came on board off the back of it simply being available. The second purpose was instrument data itself, where we had to load an enormous amount of financial instrument data into our Tivio search engine. And again, the same kind of problem really, although not to the degree of the time series, but we had a lot of departmental systems that would feed the search engine. Always going back to those departmental systems put an enormous strain on them if we had to ever rebuild the search index. So very, very quickly, Cassandra was used almost like a document store, if you will, to bring data from our departmental systems, make it readily available, keep it refreshed, and allow the other parts of our platform to access that very, very quickly and refresh very, very quickly from it. And then the sort of human side of, we've no longer just got this relational database, this managed service. We now have this Cassandra store. There was a whole bunch of different use cases where people started to put data into Cassandra. I mean, developers tend to get a little trigger happy when they get new technology, so in a few edge cases they didn't necessarily pick the right store. But generally there was different, if there was a need to store some data down, then people were looking to Cassandra because it was very quick and very straightforward to get data in and get data out. So there was a number of additional purposes it got used for. We made a few choices around how to store this data. The first one is natural keys. So in Cassandra, you have rows or petitions, I think they're called now, and columns. In our case, if you look at our use case, it was really as a distributed cache. So natural keys made sense because we're not mastering data into Cassandra. We are pulling the data up from the mastering systems, and then we're making it very quickly available. So being able to use natural keys, humanly readable keys, right from a user typing in something or picking something in search, coming down to get that data, that made a lot of sense in our use case. The time series itself, being able to store that in a single row in Cassandra so that all of that data is kept together. And again, the storage pattern of an ordered column allows you to get hold of that data very, very naturally and very, very optimized for that kind of querying that we're going to be doing. And then, as I say, with the other use cases where we were storing other types of data like the financial instrument data and other stores, the only consideration we had to have was, is this data atomic? It doesn't involve lots of relationships and joins and things, and so data is stored again in rows that naturally collect related data together, but in columns that keep them separate so that you have the atomic nature of pieces of data that go to make up the collection. So in the case of instrument data, you may have 3 or 4 different feeds of information that go to make up all of that instrument's data. So putting that all on the same row in the same way that we do all the same time series on the row, putting all of the reference data, chunks, if you will, or documents into the same row made a lot of sense. And when it came to the additional storage areas, like I say, there was a lot of use cases here, from very skinny tables of key values, binary blobs for images. Cassandra really just didn't have a problem. The key was, do you have relationships, or do you need to just store chunks of data that you want to be able to query efficiently and get out quickly? This diagram just kind of illustrates that natural fit of time series data going into Cassandra. We have the feeds from our departmental systems coming up, loading the data into Cassandra, using natural keys for the rows, and then obviously the variable width per instrument, depending on how much time series data we have. It may be going all the way back to 1900s, or it may only be going back a few years or a few months, depending on the age of that particular instrument. But using the time in the column to be automatically sorted, that allows you to go in very, very quickly and say, we want the last 3 months, thank you very much, or we want to go back on our charting and get 3 months a year ago. Very, very quick, very efficient. Worked extremely well for us. Upgrades is not always something that when you start to introduce something new, you really stop to think about. Or certainly I've worked in several places where there's been a push for a new technology and people are very enthusiastic because it solves a problem, but they haven't really thought through the whole life cycle, the total cost of that, of introducing that technology. So to touch on the upgrades we've been through, as I say, we went live with version 0.7. Only a couple of data centers, 5 nodes each. We then had to upgrade that to the 1.0 release. That was a little bit more work for us because at the time the tooling wasn't around to sort of reconcile that data. So we were kind of nervous about going from a 0.7 release to a 1.0 release in case any of the data was lost. So we spent a little bit of extra effort there to make sure that that was all sound, that we had the checks in place to be able to check some of the data before and afterwards. But that went through very, very smoothly. Just, there was no surprises out of that. And then more recently this year, we've upgraded to Cassandra 2.0 through the DataStax product, and that was incredibly smooth as well. And those kinds of lessons on a journey like this is quite important because, as a big organization, we don't like to go through these upgrades very often. It's actually quite hard to get the time to tell the business, we're going to have to sort of divert some of your precious resources onto upgrading a database technology. What am I going to get for it? A bit of performance, maybe something else. It doesn't go down very well. So you want it to be painless, you want it to be reasonably efficient, and in our cases, we've not had any difficulties there. We are using the Thrift driver, which is why the last point's there, because it was 5 years ago. Obviously, SQL is very new. We're currently in the process of looking at migrating everything over to SQL, and I can only say that's another step in a positive direction. It looks very, very, very promising indeed. Okay, so what we learned. Through this process, we did go through several pain points, around the testing, and I'll share those with you. Really, really wide columns. So we built our own indexes because the local indexes that Cassandra supports were not suitable for the kind of lookups that we wanted to do. But in our urgency, we kind of put too much into one row. To its credit, Cassandra simply complained and said, I'm really quite badly hurt, my memory's not doing so good. And it was very, very easy to see how we should have chunked that down and broken it out into different partitions in order to spread that load across the different Cassandra nodes. That was quite a big one for us, but again, it was nice to see that Cassandra sort of dealt with it. Yes, it complained as it should, but it didn't fall on its knees and give up. It limped its way through and it kept going. It just was reporting the fact that we had too much data in one row and we were trying to get too much in one chunk. The tombstones was another one where when you're putting in lots of data into Cassandra and then you're trying to clear it out, Cassandra will take a while to actually flush away what they call the tombstones through the compaction process. And if you use the default compaction strategy, then you have a lot of these tombstones building up, then you will get timeouts because Cassandra's effectively having to seek its way past lots of tombstones in order to get to the real data. But again, changing to leveled compaction has leveled that out and removed that problem. Performance tuning, this is something that you can, when a product works, you tend not to spend a lot of time on the tuning, but we got a lot of value from actually looking at the settings that we had in Cassandra, the memory in particular, and making sure that things were set up correctly. And using the natural keys for the actual data itself, which is the primary use case, worked very well, but if you iterate through partition keys, then it's quite a slow process. So looking at creating your own indexes so that you can do fast query lookups, that was another lesson that we learned there. So just a couple of things if you are thinking about picking up Cassandra. Natural keys versus your GUIDs, your surrogate keys. I think that depends very much on your use case. Like I say, we're really using this as a cache, a distributed cache, so natural keys made sense, but if I'm mastering data, then I probably would want to go with a key. And thinking about your queries and understanding how how the table model of rows and the ordered column names works to your advantage for the different use cases that you have. And your time to live, so how quickly something is going to stick around after you've deleted it is something else you might want to think about. But being able to expire data without having to write your own code is extremely handy. So I guess this all comes down to just really knowing your database. You can pick Cassandra up, you can run with it, you can throw data in, and like I say, even when you're not doing it particularly efficiently, it usually does a pretty good job of just handling it. But it does make a lot of sense to understand how your rows and your columns are ordered, how your queries, how you're going to pull out that data, and to tweak some of those database settings just to make sure that that you get the best performance possible, because you can make quite a bit of difference there. These are some of the front-end charts that are pulling data from Cassandra. This was our solution for highly scalable time series data, and it's been a very, very successful implementation. So just to round off, overall, Cassandra did just work. Like I say, even 5 years ago on a 0.6, 0.7 version, it works, and it worked extremely well. It has that time series sweet spot because of the column ordering, if you use that standard pattern. And it's extremely good at taking a lot of writes and even a lot of reads across a globally distributed cluster. So overall, I think our production support department that obviously have to maintain and look after issues around a number of data technologies as well as other infrastructure, they really just don't have a lot of problems with Cassandra at all. I think it's probably their favorite out of all of them because we've not had production issues that have caused them any pain. So that's another good endorsement. That pretty much rounds it up for me. Thank you very much for listening. I'm happy to take questions now or outside afterwards if there's anything anybody wants to know.
What's the volume of data that you store in the system?
It's about 20 million financial instrument data records, blobs if you will, which are then broken up into different chunks, and about 5 million on instruments that actually have a decent amount of time series. And that covers equities, FX, bonds, IRS. It spans all of them from lots of different systems around the globe. So I can see somebody there.
Hi, you spoke earlier about time series data and focus on that.
Yeah.
You also said there was a secondary use case around instrument data.
Yeah.
Is that typical kind of reference data?
Yes, instrument. I mean, it gets called instrument reference data, instrument static data. It's your, it has data like the different identifiers, classification, the currency, all of the metadata around that financial instrument.
How did you model that? Was the considerations for modeling and structuring the data very different to how you did the time series data? I presume it was. It was different in that instead of having time across the columns, we had effectively the documents across the columns that made up that entire instrument's reference data. So for a bond, you would have issue, and you'd have schedules, and you'd have ratings, and so you'd have all of these pieces that made up that entire financial instrument. They would come in from different sources, and Cassandra is very good for that atomic storing of data and retrieving of data. You don't want to be trying to merge it at the Cassandra level. You want to keep those blobs, if you will, separate, but together in the row for that instrument. So the same kind of conceptual model is there, that an instrument's data is in one row, so that it's all together, it's on the same nodes, and when you want to grab it all, you've got it all there to hand. But the columns are then used slightly differently, because instead of time series, you have different
chunks of data that go to make up that full picture. Okay. Any other questions? Oh,
Initially it took several months to set this up. What was the time spent?
I wasn't actually around when they did the evaluation in the first setup. I think, a lot of the time will have been spent just comparing, loading the time series data from the departmental systems into Cassandra and the others that they were investigating, and then obviously hitting those to read. But the pain points I was alluding to was more the fact that it was in beta, there wasn't a lot of documentation. Now we have a lot of good material out there for the different versions. Back then there wasn't a lot, so you had to really just experiment, and that's where a lot of the time was taken.
Just to follow up on the first question, did you have any historical requirements for your instrument data? So did you have any requirements that you need to go back in time to see how?
For the reference data, you mean? We've thought about adding that into the... we don't have a requirement for our current use case, because here we are, again, using it as a distributed cache to pull data from other mastering systems to protect those systems when we need to reload it into the search engine. But we have thought about using Cassandra for, if you will, the time series of reference data as well. And there are actually a number of, I call them spin-offs, they're not really spin-offs, but there's a number of departments that are now using Cassandra. They're either about to go into production or they are close to going into production, and that's one of the use cases. But they're a lot bigger than this one. This is just the oldest, if you will, of all of them.
I have a bank who is considering retail banking transaction with the identity data, combining the identity data. It's about 36 terabytes. They're considering SAS, Evolution R, and Cassandra. Which one you choose? Because all three UBS got it. I know you said it's more the favorite is Cassandra. Why?
So what was? So the other choice, the other.
The SAS and Evolution R.
I probably can't answer that question, to be honest. I mean, infrastructure-wise, that's not my field of expertise anyway. So that's where you get into the classification and building your indexes for that particular query. So that's where we created various indexes for different sorts of lookups where we wanted to classify instruments together and then be able to come in and grab them. So it just creates that fast response to be able to say, give me all the instruments of this classification, and then I can go away and pull that data down that I need, for, very, very quickly on each of those. But it's building your own indexes. Okay, I think there was some hands over there, but I've gone there.
You're replicating globally, are you?
Yes.
And what sort of consistency
Each data center is 5 nodes and standard 3 node replication.
And local forward?
Yeah.
Read and write?
Yes. Yeah, but we haven't really had. I know there's certain use cases where it makes sense to change that, but most of our use cases, this is, perfectly fine. Makes a lot of sense.
And do you find the replicating globally just works? There wasn't any,
yes, and it's got very good settings in terms of being able to tune throughput and things as well, because when we went out to Sydney, for example, there's a lot more latency there, and we didn't want to bring down the pipe there. So being able to set a throughput on the replication was a good benefit, because we could tell the network guys, we're not going to take up all your bandwidth just because we're happening to be bulk loading lots of data. You can throttle that, so it's very good. Any other questions?
You mentioned about working on a thread, you are trying to migrate to stacks. What are the reasons you want to migrate to? Is it only technology updates, and what are the implementation changes that you are planning?
Well, being able to query some of these data with a simple select statement is a big benefit. With the thrift model, unless we build the tools ourselves to pull out our data and to show it, you don't really get a lot out the box. And with the introduction of CQL, you can use CQL to query our thrift tables, but you get a lot of blobs, which isn't very helpful. So it's partly being able to query the, just to be able to run some routine maintenance if there is an issue with an instrument, then not having to develop a specific tool to pull that data out, to just be able to do a select statement and have a look at the data is one motivation. The other motivation is the fact that you may have seen from some of the other, from the keynote speech, for example, that CQL as a performance-tuned driver that is being taken forward is going to outstrip the thrift driver more and more as time goes on. So I see the thrift implementation as something that's going to go end of life at some point, and that's the secondary reason for. We just use the standard thrift driver. Don't use the Netflix one now. And then we'll be looking to use the standard DataStax Java driver for CQL.
I think if people started using the old method and you are trying to completely change to the SQL, how about the training? Are you going to do the training again?
There is a learning curve in that process, but what we've been able to do so far is recreate, if you will, the same sorts of models that we've got from our thrift in CQL. So it's really more a case of choosing the timing. Whenever we're going to go in and do a little bit of maintenance or enhancements for the business, then at that point we'll probably flick it over.
So model should be different, right? The modeling between the thrift and the SQL.
One of the tricks I blogged about was to create your table in CQL and then go into the Cassandra CLI and have a look at exactly how your data is being stored. You'll very quickly be able to see how that CQL partition key and the column keys end up actually in the storage engine. In some ways, it'll be a shame when they deprecate that, because it's a very nice, it's very comforting to be able to create that CQL, for me anyway, having built it once in Thrift, to then be able to check that actually what I've defined in CQL is storing the way I know it should be storing in Thrift. Yes, sir.
Quick one on availability. Are you available? Is the cluster available 24/7? What kind of availability you had over the past couple of years?
Yeah, we could be, but in all honesty, and certainly the cluster runs 24/7. We haven't had any outages, we haven't had any problems. But in reality, our customers aren't around at the weekend, and there's all sorts of maintenance goes on in the infrastructure world. So if we ever do need a chunk of downtime, we do have that luxury of being able to take a few hours out at the weekends.
So inside the sort of 5-day week that the financial industry runs inside, you've got 100% uptime?
Honestly, we haven't had any outages. So, okay, I think I'm out of time actually, but I'll be outside if anybody needs them. Thank you.